Hello friends, welcome to the next problem which says the language is L is equal to A raised to n, B raised to 3n where n's value is greater than equal to 1. So let's get started with the problem. So friends, if we have given a thought on what can be done with the problem, I am very sure everyone might be thinking that this problem is as good as of the form A raised to n, B raised to n. Yes, you are right. The problem is of the same form, but you won't be able to solve the problem because this type of problem we are doing for the first time. And it is a very important type of problem. The logic is the same. I say for every A, push 1x. And for every 3 B's, pop 1x. Now with this logic, you will be able to solve the problem depending upon the understanding of the previous problem. But the way we are going to solve the problem is now going to be a optimal way. The previous problems were solved somewhat suboptimally. Now I will say we are going to solve the problem in an optimal way such that the number of the states required will be minimum. So let's think whatever we're going to do. So as of now, let me write the logic first. So in the solution, I say for each A, push 1x on the stack. For every 3 B's, pop 1x from the stack. So let's see. Assuming n equal to 3, I have 3 A's and total of 9 B's with me. This is my stack. Bottom is R. For A, I push 1x. For A, I push 1x. For A, I push 1x. Now, the moment I get the first B, do not touch the stack. The moment I get a second B after the first B, still do not touch the stack. And the moment I get the third B, I'm going to pop just one topmost symbol of the stack. So on occurrence of 3 consecutive B's, I'm going to pop one X from the stack. So friends, how is the machine going to keep a track of 3 consecutive B's? Exactly as we did in the previous problem, that it is going to have a state change now. So we have my state maybe Q0 where I receive a and I keep on pushing X. Then for the first time when I get a B, I say do not touch the stack and change the state. Then for the next time when I get a B, I say do not change the state and go to the next state. For the third time when I receive a B, I say perform a pop operation. So since it is a pop operation now, after the third B, I am not going to go back to my state Q0. Instead, I will be going to a new state because that was the rule. Every time we change from push to pop, we have to change the state. So I say this is basically my pop state. I receive a third B and I say pop now, right? Now what are we going to do after this? This is going to guarantee that 1x will be popped after 3 occurrences of B. Now next time what is going to happen is one more B is going to come, right? And now one more B comes over here. You will say that let us go from Q3 to Q4, Q4 to Q5 and Q5 to Q3. Then again let Q3, Q4, Q5 repeat in a cycle. You're absolutely right. That is possible. But as I told you in the start of the problem, we are thinking of an optimal solution. Now the trick over here is, once I say Q2 is receiving the input symbol B, that is the first B I am talking of, I am going to say that we are reusing the state and taking it to state Q1. Now what am I basically doing over here? I say the moment I receive the first B, do not touch the stack but go to Q1. In Q1 when you receive second B, do not touch the stack and go to Q2. In Q2 when you receive the third B, perform the pop operation and go to state Q3. As simple as that. So what have I basically done is, instead of adding two more states, I have reused the available two states. So I have saved on the states, I have saved on the memory. So the machine is going to save on the memory, and that's how the machine is going to be more efficient in terms of space complexity. Going further ahead, I receive in Q3 a B that takes me to Q1, second B that takes me to Q2, third B that takes me to Q3 again, which performs the pop operation. Now after this, it is confirmed that we have to compulsorily receive an epsilon. So if I receive a epsilon and the stack top is R, I say don't do anything, simply go to the final state and conclude the machine is working, right? Now this is again the rough representation. Then you will be writing the implementation function, and from the implementation function you will be drawing a concrete transition diagram, right? This diagram which we draw is only for the reference. This is as good as hunting for the solution. Once we get the solution, it is merely a matter of representation. So let's go to the representation now. Now I have over here input as 2 A's and let us consider 6 B's. So I have my n equal to 3 over here. Bottom is R. I have my del. I am in state Q0. Input is A. Stack top is R. Then this is the first time I say perform the push operation, and over this R, X is going to be pushed, and that is how we do it. So this is for my first A. Then my second A will come. So when the second A comes, I am in Q0, input is A and the stack top is X. What is going to happen over here? I remain in Q0, over the X I push one more X, and now we know that this logic is going to work for all of the remaining A's. Going ahead, now I am currently in my state Q0, and with this I have 2x's pushed over here. For the first time I receive a B and the stack top is still X. I say do not do anything, therefore only a state change is required, and I say it will have X on the stack. Then I am in state Q1. I receive one more B and the stack is still having the topmost symbol as X. Again I say do not do anything and simply change the state, and stack will remain as it is. Next time I am in state Q2. I receive the third B. Stack top is X. This time I know that there are 3 consecutive occurrences of B, signifying I have to do one pop operation now. Since one pop operation is going to be there, we have to change the state, and therefore I say go to a totally new state Q3. Since pop operation is performed, comma epsilon, that pops this symbol from the stack. So my 3 B's and 1 X is out. Next time I receive a B. So I'm in state Q3. I receive a B and the stack top is still X. Now remember the diagram. Q3 on receiving B when the stack top is X, not R of course, when the stack top is X. So when the stack top is X, it is going to go to Q1. So we write over here, it goes to Q1 and does not touch anything on the stack. So precisely I would say that this is a transition effect from here to this state, right? Now when in Q1 I receive one more B on the input symbol B and the stack top as X, I go to Q2 and do not touch the stack. When in Q2 I receive one more B when the stack top is X, I say go to state Q3 and perform the pop operation on the stack. Now once this pop operation is performed, I am currently in state Q3. So friends, I am currently in this state, the one which I have underlined right now, right? So now after this, the input symbol received is going to be epsilon. So you have to be very careful over here that now the next transition will be starting from state Q3 and not Q1. So you have to think of the logical aspect over here. The zigzag underlined part is going to be the state in which the machine has finally landed after performing all the pop operations. So I start from there off. In state Q3, I receive a epsilon, and if the stack top is R, I conclude that yes, I can go to the final state, and that is the end of the push down automata. Now it is the time to confirm it with the help of an example. So let's do it. So friends, let's consider an example, maybe like the same one which we considered. I'm in QS AA followed by total of n equal to 3, signifying 6 B's, and the stack top as R. So now QS on A when the stack top is R, labeling the rules 1, 2, 3, 4, 5, 6, 7. Using the rule 1, I say go to state, starting from Q0, go to state Q0 only. I have single A followed by 6 B's and push 1 X on the stack. Then I'm in state Q0. Once I receive A again, I remain in Q0. I have 6 B's and I push 1 more X in the stack using the rule 2. Now Q0 on receiving B when the stack top is X, using rule 3, I say simply change the state. I have 5 B's with me and do not touch the stack. Then further, I have state Q1 on B when the stack top is X. Using the rule 4, I go to state Q2. I have 4 B's with me and I still do not touch the stack. Then I have Q2 on B when the stack top is X. Using the rule 5, I go to Q3, perform the pop operation having only 3 B's on the stack, and X will be out of the stack. Now going further, Q3 on B when the stack top is X is going to repeat the operation for 3 B's. That is, from here Q3 on B when the stack top is X, using rule 6, is going to Q1 having 2 B's and XR on the stack. Then Q1 on B when the stack top is X, using rule 4, goes to Q2, comma B, comma XR on the stack. Then Q2 on B when the stack top is X, using rule 5, goes to Q3, nothing is left as input, and X will be popped from the stack. Lastly, Q3 on epsilon when the stack top is R, finally using my rule number 7, I say QF comma R. Therefore, I say the machine is going to accept the input. So with this friends, we complete this problem. See you in the next session. Thank you.